What if everything we think we know about the universe is wrong? For centuries, we've looked up at the night sky, trying to understand the shape and structure of everything that exists. Is the universe endless? Does it curve back on itself? Or is it something even stranger? Most of us assume space stretches infinitely in all directions. But what if, at the most fundamental level, the universe is actually flat? Modern physics is built on Einstein's theory of relativity, which tells us that space and time are like a fabric, something that bends and warps under the pull of gravity. According to this theory, the universe could take one of three possible shapes. It could be spherical, curving back on itself like a giant cosmic globe. It could be hyperbolic, curving outward like a vast, endless saddle. Or it could be perfectly flat, stretching forever in a straight, Euclidean way. But what does that really mean? A flat universe doesn't mean we're living on some kind of cosmic pancake. It means that, on the largest scales, space follows the simple geometry we're used to, where parallel lines never meet, and the angles of a massive triangle add up to exactly 180 degrees. If that's true, it changes everything. It affects how we understand time, gravity, and even the ultimate fate of the universe. But how can we test this? What evidence do we have? And if the universe really is flat, what does that say about reality itself? These are the questions we're about to explore. And the answers? They might just turn everything you thought you knew upside down. The universe is vast, but does it have a shape? At first glance, space might seem infinite, stretching endlessly in every direction. But in reality, its shape is determined by the fundamental laws of physics. According to Einstein's theory of relativity, space isn't just an empty void. It's a dynamic fabric that can bend, stretch, and curve under the influence of gravity. If space is closed, the universe is like a giant sphere. Imagine traveling in a straight line through the cosmos. Eventually, you'd find yourself back where you started, just like walking around the surface of the Earth. In a closed universe, gravity is strong enough to eventually slow expansion to a halt and even reverse it, leading to a future collapse known as the Big Crunch. If space is open, the universe is shaped more like a vast, endless saddle. Here, space curves outward, expanding forever at an ever-increasing rate. In this kind of universe, gravity isn't strong enough to counteract expansion, and everything drifts apart endlessly. Then there's the third possibility, a flat universe. In this scenario, space isn't curved at all. It follows the simple, familiar rules of Euclidean geometry, where parallel lines never meet, and the angles of a triangle always add up to 180 degrees. If the universe is truly flat, it means that its overall density, determined by all the matter and energy it contains, is perfectly balanced at a critical point, where gravity and expansion are in delicate equilibrium. But what determines the universe's shape? It all comes down to density, the combined mass and energy of everything that exists: galaxies, stars, dark matter, and even the mysterious dark energy decide whether space curves inward, outward, or not at all. So, how do we measure this? How can we be sure what kind of universe we live in? That's where science gets truly fascinating. Imagine a universe with no curvature, where space stretches out in perfect Euclidean geometry. If the universe were truly flat, it would have profound implications on several of the most fundamental aspects of physics. Everything from the laws of gravity to the fate of the cosmos itself. My theory of relativity tells us that gravity bends space-time, affecting orbits and light. In a flat universe, gravity would behave according to simple, unaltered predictions, without the need for adjustments for curvature. This could deepen our understanding of black holes, gravitational waves, and time itself. Quantum mechanics governs the smallest scales, with phenomena like superposition and entanglement. If the universe were flat, it might offer new insights into reconciling gravity and quantum physics, bringing us closer to a unified theory of quantum gravity. The fate of the universe, eternal expansion, or the Big Rip. In a flat universe, expansion would continue forever but slow down, leading to a cold, empty cosmos. Alternatively, if dark energy behaves unpredictably, it could cause the Big Rip, tearing apart galaxies, stars, and even atoms. The universe's fate depends on the mysterious nature of dark energy. A flat universe might suggest a multiverse, an infinite number of parallel universes, each with different physical laws. If our universe is flat, it could be just one bubble in a vast, eternal multiverse, opening new possibilities for understanding reality. What would a flat universe mean for the future of physics? It could blur the lines between science fiction and science fact, expanding our understanding of the cosmos. The idea of a flat universe is based on a concept in cosmology that suggests the geometry of the universe might be flat, as opposed to being spherical or hyperbolic. This concept is tied to the overall shape of the universe and the distribution of matter and energy within it. Here's an exploration of what it might mean if the universe were flat. 1. Cosmological geometry. In a flat universe, the space-time fabric would have zero curvature. Imagine the universe as a massive, infinite plane that stretches out in all directions, with parallel lines never meeting and angles in a triangle adding up to exactly 180 degrees. This idea contrasts with a curved universe where, depending on the curvature, straight lines could converge spherical or diverge hyperbolic. 2. Expansion of the universe. A flat universe would still be expanding, but in this scenario, the rate of expansion might slow down over time. However, because the universe is flat, it would never close in on itself. There would be no edge or boundary in a finite sense, and the expansion would continue indefinitely, possibly at a constant rate or potentially slowing down towards a halt. 3. Critical density. The flatness implies that the universe is at a critical density, meaning the total mass and energy density of the universe would be perfectly balanced. In a flat universe, the density would be exactly what is needed to stop the universe from collapsing under its own gravity, but not so much that it would pull everything back together. This delicate balance is key to the flat model of the universe. 4. Cosmological models and observations. According to the current understanding of cosmology, the universe appears to be flat based on observations of the cosmic microwave background, CMB, radiation, and the distribution of galaxies. The results from the Planck satellite and other observations support the idea that the observable universe is very close to flat, with just a tiny margin for error. 5. Implications for the future. If the universe is flat, its fate largely depends on the behavior of dark energy. Dark energy is causing the accelerated expansion of the universe, and if it continues to dominate, the universe could expand forever, with galaxies moving farther apart and stars eventually running out of fuel. If, however, dark energy's influence changes, the universe's fate could be different. Philosophical and visual implications. A flat universe could challenge our perception of space. Without curvature, light rays would travel in straight lines, making the concept of the edge of the universe meaningless. Over long distances, this could lead to an infinite, ever-expanding set of stars, galaxies, and celestial objects stretching beyond what we can currently observe. We've explored the possible shapes of the universe: closed, open, and flat, each with its own implications for the cosmos. A flat universe, in particular, raises fascinating questions about gravity, the fate of the universe, and even the possibility of a multiverse. But how sure are we about its shape? While evidence leans toward flatness, the truth remains uncertain. Could the universe have no fixed shape at all? Or is it constantly changing in ways we can't yet understand? The universe is still a mystery, one that continues to stretch the limits of our knowledge. And as we unravel its secrets, remember, the journey has only just begun. If you want to stay updated on more cosmic mysteries, don't forget to subscribe to the channel.